we are gonna real quick go back over how this one works. The process of the graphing of it, the limits and all this kind of stuff, right? Because we already did the whole integration thing. So I'm looking at this and I want to convert it into that. Like, what the heck's going on? I guess we can. I'm gonna go the more algebraic, basic way. I'm gonna say this is a y equals, and a y equals. So I have a y equals square root of blah blah blah, right? Awesome. And I want to make it easier for myself. What could I do to make that easier? Okay, what makes it complicated? The square root. How do I get rid of it? Exactly. Exactly. Make it circle-esque. Esque? Esque. Make it circle-esque. I wonder if is that like French or something? Esque. Moving on. Yeah, moving on. This is a math class. We don't talk about that. Yeah, this is a circle. This is a circle, and so then I want to start graphing this thing as a circle. And what's the radius again? 7. Very good. That's one thing I messed up today. Just saying. Before class, I was doing all the math and messed up many times over stuff like that. Oh, why is the screen tiny? For y'all, sorry, the recording folks can't see it. Can I try to fix that real quick?
Yeah, that's fine.
Display options. Yeah, sorry guys. We're going to.
The screen or the projector?
It's the well. Let's do this. Then no, I don't want those settings. Okay, so wait, did I just keep them? Whoops. Okay, so then I'm going to only show 2.
That's only on your.
Yep, keep changes, and then now I'm gonna duplicate, and it should now be big. Okay, phew, fine. All right. Yeah, that was weird. Oh, don't look at that. Don't look at that. No, 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 no. You didn't see that. Oh wait, it was about the whole time. Whoops. Anyways, it's a circle. So we got that far. But like over here, we now have the x equals. So I got x equals 7, x equals -7. So they're saying on the x line, we're going from -7 all the way to +7. Like the whole thing. So what does that look like to you? It's a full circle. The whole circle. Not just half of it, not some cut up part of it. We got the positive, we got the negative, we got from -7 to 7. There we go. So this is what we're trying to figure out. This is our region, I guess you could say. Blah, 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 r dr d theta. So I'm wanting r equals, and then I want a theta equals, and a theta equals. So again, starting from the center, working outward, 0 to 7, 0 to 7, 0 to 7, 0 to 7, 0 to 7. So what do I put down here? And then there it is. Every time when I go out to the edge, it's 7. It doesn't change. So that's nice. And then again, how much angle do I have here? Yep, 2 pi exactly. You got it. And that's kind of what I do. Is that good? Good little review. Okay, cool. Okay, awesome. Because yeah, we're gonna need to do that again. And you can see that yes, Desmos graphing is up because I had to cheat a couple times. It makes me wonder how the exam is going to be. I need to make the exam, so I haven't done it yet for the second one. But I specifically want to avoid cardioids. So, oh, I don't want to show you all my work. No way. We're going to start fresh. But are you good here? You're good? Okay, cool. Okay, so yeah, I did not know how to graph this thing. And when I saw the when I saw the fourth quadrant of a blah blah blah, I didn't really think. I was thinking it was something kind of like this, and I wanted only this one right here, and that is not the case. A cardioid, the root word is cardioid, means heart, right? It's a heart. So that's not my shape at all. I just did not understand. So then I drew a heart, and it's like, that's wrong. So it was actually an upside down heart. How do I know these things? Desmos graphing, of course. So how would I know that without Desmos graphing? Just kind of like zoom out for a second. Give me some ideas. What if I didn't know? Like, I'm gonna prove it to you what it looks like. But how would I do that otherwise? Yep, it would take a while, but you can make a table. Make a table, slowly go through, try theta 0, theta pi over 4, theta pi over 2, and eventually you can plot every one of these points going around. You're like, oh yeah, it's a hard upside down. I don't want to put you through that on an exam, though. You know what I mean? So we'll see. We'll see. If there's no other good questions for the exam, we'll talk about it. But as of now, I don't want this on there because that's just annoying. Okay. So we're looking at the picture of this cardioid, and it looks kind of like this, but they're saying only the fourth quadrant down here, as in like just this chunk down here, and they say find the area, and that's it. It's not too bad, right? Until it is. So I need to set up my area formula, I guess you can say. I got a double integral of 1 r dr d theta. And let's just pause on that. You know how volume I go to triple integral of 1, right? Well, now I'm just doing double integral for area. It's kind of like I'm saying double integral of 1 dA. But what I'm doing, I know ahead of time I'm going to translate it into polar, right? So I'm kind of like already doing that. And when you do that as a requirement, right, R is required. I have to have that R in there. So far, so good? Just kind of like a review of what we were doing. So the goal then is to find the limits. I need to know what my limits are going to be for this double integral. So I'm going to give myself a little bit of room. So this is an R equals, this is an R equals, and then I have a theta, and I have a theta. Right, those are going to be what I need. Once I do it, I pop it all in, we're done. So let's zoom in. Boom. Like, this is what we're trying to integrate, right? And it seems like I'm going to go from 0 to something, 0 to something, 0 to something. And it's changing all the time. What would be that something that I'm going until? That's changing. Yeah, the function, the thing they gave us, right? Yeah. So we're going 0 to that stuff. I have to make some room there. Go ahead. Bro, you made my life so much easier. Dude, like, I seriously spent 15 minutes trying to figure out a way to figure out how to get to what you just said in like 2 seconds. So thank you. Oh, good. All right. Well, me too, and I still didn't figure it out. So that was a good point there. So let's talk about that here in a second. But are y'all okay seeing that I have to go from 0 to something? And look, it says R equals, so it's like we got to use it somewhere, right? Cool. Good. Okay. So now we're looking for thetas. Well, James just said, hey, we know it's quadrant 4, so why don't we just say 3 pi over 2 to 2 pi? And I'm like, well, wow, that was so easy. Can I tell you what I was trying to do before class? I took this thing and I said, whoa, I know that it's going to be set equal to 0, so then I need to solve for that, blah, 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 and I found all the, 2 pi n. Do you know what I'm talking about from pre-cal? The 2 pi n answers? We don't want to do that. And then I was like, but why is it not doing something or other here? So I had to go and calculate for when it's this and that. And the blah, 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 blah. It's super easy. Quadrant 4. It's right here. That's it. Thank you. Thank you. All right. So we set it all up. Now it's just integration. Do you want this to be a you-do? No? Okay. So of 1 r dr d theta, here we go. What's my integral in terms of r? r squared. Very good. You know that I messed up that this morning as well. I mean, I'm just a constant messer upper. So there we go. Very good. Let's put the 1/2 in the front. Oh, you know what? I'm writing too big again. Keep it up. Just keep it up. Let's keep going. Write it huge. And so then I've got this stuff here, and all of that squared d theta big pause. Oh, I've literally ran out of room. I'll just like never get enough room here. Look, well, I'll just use the top of this thing. Okay, so we have this funny little square thing here. Are y'all good with integrating the big square? No? Me neither. There's not a formula for this, especially with a plus sign in there. I don't know of anything like that will do that. So what could I do to simplify this a little bit? Yes, separate them, 2 of them. Very good. And then because there's 2 of them, to simplify further, what is it called? What would I do with these 2 things? Foil, but yeah. Is that one or the other? It starts with an F. So yes, exactly. 5 times 5, 25. I got a what? Yeah. That's funny. That's a calculus joke. 5 times 5 is 25 again, sine squared. Oof. Do you really like what we just did? It does make it, some parts at least, a little easier. So I want to integrate 25 in terms of theta. Very good. 25 theta, very good. So that's an easy one. And be careful with this because this is where I messed it up. What's my integral of sine? There it is. It's negative cosine. I spent another 15 minutes saying, why do they have a negative? I mean, I was so frustrated. It's because of the integration. I mean, gosh, man. And then finally, everyone's favorite. What's the integral of sine squared? It's a good thing that we have formula books for this. So again, is this a good one for an exam? No. That's a no. Unless I tell you the formulas ahead of time, right? I would have to say, hey, make sure you got sine squared on there. So I'm just going to give it to you because the 25 stays in the front. The rest is very straightforward from the formula book. 1/2 times theta minus sine theta cosine theta. That's the formula for it. So like literally sine squared turned into this dude. And then I'm going from 3 pi over 2 to 2 pi. That's a lot of parentheses. Thankfully, a lot of this will cancel. So I'm going to plug in the 2 pi. So I got 50 pi, I guess. Plug in the 2 pi here. What's cosine of 2 pi? Just 1, very good. Therefore, we say just minus 50. Excellent. When I plug a 2 pi in there, this is when things get a little weird. I got 1/2 times the 2. It's just a pi, and we got the 25. So 25 the pi, 25 pi. And then when I plug 2 pi into one of these guys, one of them is going to end up being 0. Therefore, I don't have to do it. So I just don't write it. Did you see how I messed up? I messed up something from here to here. What did I do? Come on, tell me. With a 1/2. Oh, gosh. Bad Chad. I knew I would mess something up along the way. There's so many numbers. Yeah, there's a 1/2 in the front. Okay, keep going. 3 pi over 2. I plug it in. It's just sad. That's just what it is. 75 pi over 2, I guess. I don't know. When I plug 3 pi over 2 into cosine, 0, very good, 0. So I don't do anything there. 3 pi over 2 here, super sad. So that would be a 75 over 4. And then again, if I plug in 3 pi over 2 to one of these guys, one of them is going to be a 0 again. Yeah. So this is my answer, Desmos, and you're disappointed again because it's pies. We have to do the math. Ugh. Yeah, you know what? We could do all the pi things without the pi. You're tempting me. I'm going to do it. Oh, you can see I already started doing it. Yes, yes. I tried all kinds of things to make this thing work. So yeah, 1/2, and I'm just doing the pi answers. So we got a 50, and then I got a plus 25, and then I got another 1/2, and I got a 75 over 2, and then I got a 75 over 4. And so it would be then 75 over 8 pi. So that was my pi's, right? But the numbers, the only one that's the number is this guy, right? So 1/2 times this guy. And there we go. Flash the answer, and we got it. You can see all the work that I did here too. I wrote tinier. Maybe I should write tinier. Yes, Chad. That would be pretty funny. You just type this thing in. Try that out. Tell me what happens, because that's a good one. Okay. Whew. That's today. Today is one of those days. Yeah. Good? Yes. Is this okay, though? Good, good, good. You're still writing over there? I'll wait. You're good? You're just doodling. Okay. So find the area between these two regions. Again, I don't know. These are cardioids. I don't know what cardioids are, and because I didn't know how to graph it well, I messed this one up again. So again, let's just kind of use what we got to help us just a tiny bit. If you think about the patterns, you could at least get some of the idea here, because instead of a sine, it's a cosine. Therefore, it's like a sideways heart. What gets me is the plus and the minus. And it seems that the plus or the minus is indicating where the tip is going. And so like last time when we had right here a plus, it was going up with the tip. Like the bottom tip, I guess you could say, was positive. I don't know. And then so this one here would be positive. That one's this guy. Exactly. Cosines are horizontal hearts. And then we got the plus is going to go this way. The minus is going to go that way. Yep. So just kind of like, but do we really need that? Probably not. Because they're wanting to know where these intersect. And I know that I'm already graphed it already over there, but they're wanting to know this in-between zone. Right? They say, what's the region between them? And you can see we got two little hump thingies, tiers. I don't know, whatever you want to call them. Huh? Okay. But here's the thing, though. I think trying to go, like if you zoom in here on this little graph, if you're trying to go from 0 out to a thing, we're going to go 0 to the black, and then we switch over and go 0 to the red. Is this like two separate integrals? Ugh. I can at least say that everything's symmetric. So, what if I were to do only one of them? Like, what if my graph was only this guy, and then I said times 4, because there's 4 of these little halves here. Like quadrant 1 only times 4. Is that good? Would that make sense for y'all? Because they're symmetric. So then let's set this up. I got 4 times double integral of 1r dr d theta. And again, because I'm only looking at quadrant 1, that's 0 to 2 pi. That's quadrant 1 stuff. But then I'm going from 0 to what? Which one of these? The plus or the minus? It's the what? It's the minus, because the minus one, yeah, you could see from the graph it's the black one. But the minus, because its tip went to negative, I'm looking at its hump in the positive. So yes, I'm looking at the minus version. And there's another reason why I got it wrong this morning. So, like, I'm just telling you where I got it wrong. I'm making a point about it. You know what I mean? Like, don't do what I did. Okay, now I'm going to try to write tiny. At least I'm going to try. Okay, so 4 in the front. Integrate. I'm integrating r. And so I get what? There you go. Very good. R squared over 2. Plugging in 0 and this 1 over 1 minus cosine business. There's now a 2 in the front if you combine a half and the 4. One minus cosine all squared. And what did we do last time with that thing? We foiled it out. You got it. Very good. Very good. So I'm going to like skip to the end of the foiling. I figure at this point we're foiling masters. And then I send you back to my college algebra. You're like, what's going on? Well, it's a tough class, though. So some of these integrals are super easy, right? The 1, the 2 cosine, but the cosine squared, again, we need a formula. This would be the same thing as the sine, except for it would be a negative. Boom. How did you know that? Oh no, the mute was on. For how long, I don't know. It's okay. The mute was on for a second. It was because I pressed it. But see, come on now. There you go. Yeah. All right, 100%. 100%. So, yeah, the cosine is the same thing. We got a half in the front, theta, and then minus sine theta, cosine theta. And then another one. No. Actually, we don't need that other one. We only need 2 this time. So that's kind of cool. From 0 to pi over 2. When I plug in the pi over 2, I get pi over 2. Sine of pi over 2. Very good. Plug it in here, I actually get pi over 4. And then again, whenever I plug pi over 2 into one of these guys, one of them is going to be a 0. So I don't need it. Plugging in a 0, I get a 0. Sine of 0. 0 again. 0, 0. Everything's a 0. We don't need that. So I have 3 pi over 4, and then times a 2 in the front. And then I got 2 times 2 is 4. 6 pi over 4. 3 pi over 2. There we go. Let me just verify. Flash the answer, and you can see I did all my cool work there too. So, yep, there we go. We did it! I need to have a you do now. Yeah. One of the things that you might have seen in Cal 2 is the area formula in polar form. And this is just the double integral, but we integrated it. So now you know where it came from in a way. Yeah. Yep. Exactly. So that's pretty cool. I mean, it's like, oh wow, that's where it came from. Good. Yes. And then you get to proofs, and you wonder, like, where did we get addition? Yeah, exactly. Yeah. Right. We have to have some axioms. Addition, less than, but not greater than. They can't have that, right? So next one, unless y'all, are y'all good with this? We're good. All right, here we go. This one, I messed this one up terribly. So I saw average. I got a formula for that. Yay! Double integral of f dA divided by double integral dA. Like, that was easy. I was like, yeah, feeling good about this. Oh, and look, that's my function. Let's plug it in. No. I actually had to go to the homework and look at the view and example thingy to go and get what they were doing. So let's try to figure out what's going on here. This is a good formula, but we've got to alter it a little bit. So we have a circle, and it's supposed to be radius of 9. So, or I'm sorry, not radius 9. See, I'm already messing up again. 3. See, I messed that up too. Exactly. They're saying like the whole inside of this thing, right? What they're wanting though is the distance from the origin, the average distance from the origin. So like from here to here, I mean, if you're looking at it, we got 0 to 3. It looks like 1.5, right? That's right. They're saying any point. We could start here at 1 and go to 3. We could start at 2 and go to 3. And all these other things. And yeah, you're right. There's a lot more on the edges. So it's a weird concept. I've actually a little confused about what they want to do here. Essentially, they want to find the distance. And I'm going to, of course, do polar form. R dr d theta. And then this one here is just, I guess, yeah, that's fine. So it's the distance. And on a circle, I'm going to redraw the circle. How would I find the distance to the edge of the circle? It's the radius. That was perfect. 100% perfect. I mean, I wish you were here like an hour ago when I was doing this. You could have told me. I didn't have to look it up. It's the radius. And in a way, the simplified form of this is r dr d theta. My d theta didn't come out very well. And then in the bottom, I'm just going to say area because I'm going to show you a trick here in a second. It's actually really cool. It'll make it a lot easier. But yeah, this right here was that distance. It's just the radius. As in like a single r, nothing else. I know you're thinking, oh, well, r squared, blah, blah, blah. No. It's just an r. Now, there is the other required r. So technically what we have right now is r squared, right? But I keep writing this area. I'm going to give you a hint here. I want to find the area of this circle. You laugh, but we're in Cal 3. You never know. What is the area of a circle? Pi r squared. And what's my radius of the circle? Boom. And so, go ahead. 9 pi. So in the bottom, I don't have to do another integral because it's just the area of the circle. No problem. That did work, by the way, when I did it earlier today. It actually did work, so that was good. Pi r squared. It's been forever. All right, so we're going to have to integrate this r squared. What's the integral of r squared? Perfect. R cubed over 3. And I'm going from my radius again was 0 to 3. Perfect. I'll take it. 9 pi in the bottom. The 1/3 can come out to the front. I plug in the 3 cubed is 27. Oh, yeah. And then you plug in the 0 and it goes away. So basically, I've got integral of 9. And what's my integral of 9 in terms of theta? Cool, cool. From 0 to 2 pi for a full circle. Very good. The 0 goes away, but the 2 pi, I get 18 pi over 9 pi. 2. 2. And yes, let me flash the answer. Answer is 2. There you go. 2. That was a lot easier now that y'all were here. Gosh, man. We should take all of our tests collaboratively. Oh, I just recorded that. Okay. Well. Just because I say it doesn't mean it's going to happen. Yes, that's teaching theory stuff, which I can't be too elaborate on here. Are y'all okay with 2? It's kind of too easy, right? Too easy. Wow. And then we move on. So, and you're like, yay, triple integrals. So, like, we just keep going. It will get longer and longer. So I do want to kind of, I know we're ahead. I know. You're giving me those eyes. I know. We got 30 minutes. Unless you want me to go over some homework, I can. I don't mind.
If anybody has questions, I don't want to be the only one chatting. You do this problem, that problem.
I can do that.
All right, let me pull up my computer.
Oh, okay, cool. Yeah. Is it just so scary? Oh, no. I mean, we've done triples now at this point. I mean, look at that. It's not that hard. We'll just do it again. And there it is.
Go on forever if you wanted to. Do that for. Not to mention you already passed already implying that when we're solving for volume, where volume would just be 1 PV.
Yeah. Exactly right. Yeah. If you didn't see it, there's a little 1 right there. Okay. Yeah. Tell me some homeworks. Let's do some homework stuffs. Am I thinking it's 14.7? Yes. Okay. I'm fine with that.
Actually, a lot of problems I may or may not have Googled how to solve.
Well, that's what we're here for, to do this kind of stuff. I'm fine with that.
Part of the reason I asked for the second extension is just because I haven't touched 14.7 yet. And I've heard stories.
Oh my gosh, there's 25 on here? Who did that? Oh. Yeah.
You want to check just for that good improv? Let me find it.
Sure.
That's what I've been kind of tripping.
Oh, that's terrible. Okay, that's fine. That's fine. I love doing this stuff with you guys. This is good stuff. Let me pull up my blank piece of paper thing here. And this guy. Swoop. Whoop. And there we go. All right. So find the local mins, maxes, and everything like that. So we're doing our first derivatives. Instead of both equal to 0. That's the key trick. I know that y'all know this because you're doing it like right now, but it needs to be this and this. When I set them both equal to 0, solve, right? Whatever this is. All right, so there's a huge square root. Super scared. So I'm going to do 1/2 in the front, leave the inside alone. And then negative 1/2 power derivative of the inside is yes, 112 and 16, and then another 16, and that's it. Oh, wait. In terms of x and y. All right. Let's just do the x's. So this is fx. And like you said, it was just a 16 right there. On the outside, that is still going to be a -8 and set this whole thing equal to 0. Okay. The y would be fairly similar. I'll go ahead and write it out so that we have it. But I think the process is going to be very similar. Yeah, we leave the inside alone. That's right. Now, as you know, not all of these are going to be on the exam. So is there a way for some of these to be easier, right? I might pull out some Desmos. Don't shoot me. It'll be fine. It'll be fine in the end. Okay. So I need to basically solve both of these. In fact, you know what? Can I do a little cheat right now? Do you mind?
I've done this problem so many times I got it wrong.
Okay, I want to cheat for a moment with Desmos graphing, and I want to see if it'll get me something better than what I was hoping for. Okay, I'm going to type what we got for both of them with the x's and the y's. It should produce kind of like a graph, I guess you can say, of some kind, and then we're looking for the intersections between them. Again, I don't want this one on an exam because this one's it's not exam worthy. It's just being mean to you. See how there's a graph? So I'm assuming that the other one's going to be a graph. Where are these two touching each other? That's going to be the key here in a second. And if it's easy, then we're done. If it's not easy, then we'll look at it and figure it out.
So I do have one.
Yeah, go ahead.
About this problem. Is the questions like these on our quiz by chance?
Sure.
Okay.
I mean, I don't know. I'm not. Yeah, but that you can use Desmos on again, right? Right.
Right.
Good. Okay. So it looks like they're colliding right here. And I know that's a flat line. It kind of looks weird to me, but I mean, I guess I don't see anything else that would happen. So we need to find out where this thing is. And I know we can zoom in forever, but we're looking for. Are they wanting exact answers?
Yes.
Okay. So we're kind of in a zone here. Yeah. Back to what I was doing here. We're kind of in a zone here, and I wonder. This looks like it's just 0. And it's kind of giving us a domain, I guess. So I want to know when this blue one, when this guy is equal to 0. If I only solve the top, we should be good to go, in a way. The bottom doesn't really matter, is what I'm hoping for. So yeah, if I say just the top, only the top, and I set it equal to 0, what's the y value right here? Looks like 0. So then let's try some tricks, okay? What if I just got rid of the y, because that's a 0, and then this is all equal to 0, so the 8's still important and all that stuff. Let's try that. Let's try that right now. One other thing, these are both divisible by 2, and there's this half, so I want to cancel here. I'm basically factoring out a 2 from right here, so I would make the 56 again, and an 8, and then I would just basically get rid of this thing. Okay, so that's my small alterations. So I got 56x minus 8, and watch some other tricks that I'm going to show you here in a second. All over the square root of blah, blah, blah. Again, my y is 0. And then it equals 8. Yeah? Or I guess you could say minus 8 equals 0. Either way. I want to do that. I want to do the minus 8 equals 0 still. So I need a common denominator. Blah, 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 blah. So I do minus 8 times this big square root stuff. And then I'll have a common denominator because I put the square root in both the top and the bottom. Are you okay with that so far? So blah, 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 blah equals 0. Well, the thing is with a fraction, to set it equal to 0, we only want the top equal to 0. So then basically I just got rid of that, and I'm looking only at this thing now. Move this whole thing over to the other side. 56x minus 8 is equal to 8 times this big stuff. Is this divisible by 8?
It should be. I believe that's here 6 or 7.
That would really help here in a second. Yeah, help me out. Tell me if it's divisible.
It's 7.
Okay, excellent. I should probably have known that.
This is Cal 3. You don't do basic method here.
Yeah, we don't do that anymore. Yeah. How do I get rid of the square root?
Square it.
And when I FOIL out this side here, I think it's going to be a 14 and a 1. And then I can combine like terms. Let me scoot over for this a little bit. In fact, I can just maximize this thing. Oh yeah, we got plenty of room now. Okay, so moving everything over, 56 minus 49 would be a 7x squared. 14, when I move it over, I'm going to get a negative 2x. And then I'm going to minus 1 to make it a negative 32. I don't know how to factor that, but we could do quadratic formula, and we shouldn't be too scared of that now. And I'm doing a lot of shortcuts along the way. I wish I just had like a pocket calculator for this. Hi, it's good to see you. I need my little Desmos. Like, go away. I need my little Desmos. Here we go. Shoop. Clear all. So 4 plus 4 times 7 times 32. Oh. Oh, ho, ho, look at that, huh? Isn't that 30? Oh, a little premature there. 2 plus or minus 30 over 14. Now, we're wanting around 2. Our answer was like 2.23 or something silly like that. So let's just try the two different numbers. So I got 32. 32 over 14. There, right? That one's looking pretty sweet. And then I also got negative 28 over 14, but that was not part of my graph, at least as far as what I saw. So I'm looking at this dude and thinking, And again, that was my x equals. My y was 0. And now for the, is that a maximum or a minimum or all that kind of stuff, right? Are y'all seeing how I got to that number there, though?
I do have one question.
Yeah, please. That's why I'm here.
It's the 56x minus 8 over the square root of minus 8. Could we also plug that to Desmos to help find the...
Oh, yeah. Yeah, I probably could have done that. There's, yeah. Well, no, I used Desmos to help me a little bit. In the end, all Desmos did was let me look at the graph and make some assumptions. Got rid of the y, and I kind of knew what my answer was going to be. It was like the 2 point something. So let's go and see. I'm going to put this into the homework. So that's my answer. Let's go and get the answer, right? So maximum, minimum, this kind of thing. I have a square root with some numbers in here, right? And again, y is 0, and I got some x's and something or other. If I make more x, if I make more y, would I get bigger values or smaller values? See, I already know that I'm at the tippy top of something, or a saddle. We'll see. But if I plug in a lot more, if I make more x, would this whole thing get bigger? Like 100. What if I plug in 100? Would I get a really big number? Okay. What about my y? If I put like 100 in there, or a negative number, decrease a little bit, right? So okay, if I take my y and I'm going more y would make the whole thing go down a little bit, then I must be at a maximum. That's just my first thoughts. So let's try that. So my local maximum occurs at the 32 over 14. Is that how that works? It's like the x value, y value. Ordered pair. Thank you. You're right. So comma 0. And then this one, I just plug it back into the original. So here we go. However sad it is to do all this. Again, this might end up being on a quiz just because. And then you can yell at me. That's okay. But it's definitely not test worthy for sure. This is not a good testing thing. Okay. Well, just to make sure, okay, 16 over 7, just to make sure I'm not going to mess something up here, okay? Whoa! The first time. I'm going to say none for the others. Just hoping for the best. Look at that. Yeah? Well, there's 5 minutes of your life gone. I meant 5 hours of your life gone. But I think on the homework here, it's good to use a little bit of Desmos to help out. And if Desmos could have given me the decimal to fraction, I would have done it. You know I would have done it. And we would have been done a long time ago. And sometimes that does happen. Don't be scared to use some Desmos on the homework. It's okay. The exams will not be that. I don't want that on the exam. Cool? Show me another one. 21. Let's do it. I actually had to use Google to figure this one out. Let's do it then. Let's do it. So I don't know what I just clicked. Sorry. Go away. Blank. Refresh. Let's do this thing. Okay. So the point on the plane that is nearest to the origin. Okay, let's draw a picture. Always draw a picture. Let's try to figure out what's going on here. So I have this plane somewhere in space, and here's my origin. And I'm wanting to connect to it. I want to find that point there that's closest to it. So far, so good? In order for a plane to be close, like I'm going to do a 2D right quick. So this is the bottom. This is my XY plane, and this is Z. And I have a plane kind of like doing this, let's just say. In order to get the closest, I'm not going to go this way. I'm going to go at a normal vector. So basically, I'm looking for a normal vector for the plane, or what we would say back in the day, some slopes. We're looking for the slopes, right? To kind of indicate where we're going. Now, if this is point P, and that's the origin, and we're following the normal vector, and I want like, terminal minus initial, right? So terminal minus initial, I guess I would just say the normal vector is my vector at all, or maybe it's a negative, yeah? Or maybe it's like this way. Regardless, I'm going to get my vector for that would be 3, 4, 1. And this is going to be that traveling, I don't know, the way we're traveling. What I need to do is find out where this is, colliding, I guess you can say. Let's make a line. Let's make a 3D line in space. A 3D line. So I'm doing x is equal to, this is x naught plus a t, I guess. And I'm just going to use b and c. But these guys right here, what is this next to a variable? What do we call these things right here, these numbers? There you go. We have those. So in a way, I'm like making up my line equation. Also, knowing like where I'm starting. Where are we starting? For sure. At the origin, 0, right? So I can just say that it's going to be this thing right here. That's a 4. I'm going sideways here, I'm sorry. this line will collide with that plane at some point. In a way, I'm almost asking when. Find t such that it'll plug in. I have x equals this, y equals that, z equals that. I know it's going to touch this plane. What can I do with those x, y's, and z's? Plug them in. Let's try it. So I got 3 times 3t. I got 4 times 4t. I'm just guessing here, okay? I'm really just guessing. And hopefully this will do something here. Okay? So 9t plus 16t plus t is equal to 10. That's 26t is equal to 10. Divide, and we got when it occurred. Would that be 5 over 13? That's when it will occur, yeah? What I want to know is where. Well, it's a good thing we have x, y, and z. X is equal to 3 times t. Y is equal to 4 times t. And z is equal to t. Right? And so doing a little bit of math, we got what? 15 over 13? 20 over 13? 5 over 13. Let me try them and see what happens. Now, this is all just me thinking out loud. I haven't looked at it. I'm just kind of like, maybe this is one way we can go.
If I remember correctly, though, that's how yeah.
Boom. Look at that. Did it save you a couple hours? No, because you already wasted them. I guess in a way, what we're trying to do here is not just one formula, right? We're trying to think, how can I make this thing work spatially, I guess you could say, right? I got 4 minutes. Are you just confident or are you scared? Have you not even started? Well, it's a good thing I extended it again until Monday. Okay, cool. You got nothing else? You were claiming you had all these problems.
Well, most of them, like the one is like that, but there's another one earlier on where it's like e to the x.
Tell me, which one? Which one? Oh, you wanted me to... Oh, please, go ahead.
I believe it's like 16. I shut down my computer before.
Okay, I could look around 16. And I love doing this stuff with you guys. This is... Oh, yeah, I could see that. I could see that.
It wasn't that one.
No!
It was like e raised to variable, something like that.
E raised to a variable? 15? This,
That one.
this one's mean to you?
Yeah.
We should beat it up in the parking lot.
Is that what we do when we're solving equations?
Yeah, exactly. That's how you solve problems around here.
So the issue I'm having is you have to take the second derivative to figure out if it's a maximum or minimum. That's kind of the issue I've had with this problem.
Well, this is what I would say about that. Yes, you can always go down the formula way of doing it, or like I did with that square root problem. I was thinking, what if I added more to this or that? And I was kind of reasoning about it. So let's just say that I found a point at, I'm just going to make up 0, 0, 0 or something like that. Okay, let's just say it was that. So then if I plugged in more, then I should get bigger because you see these squares here are going to make it like bigger over time, right?
Right.
And it's squared, so those, and at least for y, it'll be going up more on the power, so bigger overall. Therefore, I was at a minimum.
Okay.
That's just an example. Now, that won't really happen because we have a negative here, and this overtakes the square initially, meaning it would be a saddle point there if we had that, blah, blah, blah. Like, we got to still solve with it, but yeah. Good?
Yes, sir. That actually answers my question.
Well, can I still do it?
Yeah, sure.
Oh, great, because we got 2 minutes. Let's do this thing. So derivative in terms of x, I basically am just taking a derivative and bringing it down. So I got a 4x minus 12 times the original. And I'm setting this equal to 0. And for the y, it would just be a 4y and then the original. Set that equal to 0. Let's pause right quick. Can e to anything ever equal 0? It can? So but maybe so, but let's think about it, okay? Because you have a point. My basic e will never be 0, right? But this is not a basic e. Is there a way for me to make it shift down from up in the power? In a way, I'm saying, like, if I did this, I know it'll go down and it'll start to collide, right? On the outside of it. But is there a way, like erase? Is there a way for me to change something up here in the power? If you remember how the power works, it's shifting side to side. And so if I shifted it side to side, it would still be above, still be above. Like, I can't make it go up and down enough outside of the power. Therefore, I think what I can assume, I'm assuming this, that all of this cannot equal to 0. Okay? And this is just my assumption. See how I'm trying to make it faster on us, right? Therefore, I'm going to focus highly on this side of things right here. Just that. Because it's, again, multiplied. They're factors, essentially, right? So then I got my 4x minus the 12 is equal to 0. And I got the, I got the 4y is equal to 0. Well, this one's easy, right? That was simple. What would this be? 3. And so this is my answer so far. At 3, 0, if I plug that in up here, like to the original up top, give me a second here. Let me see. So that would be a 9, and I got 18 minus 36. So that would be a negative 18, essentially. Okay, let's pause on this for a second. When I plug in the original, my point, I'm getting e to the negative 18, right? It's still a positive number, but that power is what I'm really focused on, right? I'm saying, okay, I got a negative 18 up there. If I plug in other things nearby, what if I plug in a 4? What if I plug in a 5? What if I plug in a 6? What if I plug in a 100? Yeah? If I plug in a 100 up here, would I get a bigger power or smaller power than negative 18? Yeah, exactly. It would go way higher. So I'm thinking if my power's bigger, then my thing is big. See y'all later. And so my power's bigger, the whole thing's bigger. Therefore, it gets to get bigger, bigger, bigger outside of it. Therefore, it was probably a minimum. Okay. At least I'm hoping. So let me go and plug it in. Let's see. So no maximum because I only got the one answer, and I'm guessing it's a minimum. Okay. It could be a saddle. Doubtful. We'll see. And so this was e to the negative 18. There we go. And then no saddles. There we go. See, I'm cheating the system. Not with Desmos. I didn't ever use Desmos. But I'm thinking rationally, like, how can I make it without doing that stupid formula?
Yeah, instead of doing the actual formula, using logic to try to figure out does this, like, how does this graph work?
Yeah, you said actual formula. I said stupid formula. It's fine.
Okay.
So, cool. Okay, thank you for 3 minutes past. I'll see y'all later. Y'all have a good day.